Hello folks, I'm back with another demo video on homework 6 this time. I do hope that you have read your lessons up to section 4, part 3. And now we can watch the demo video and you should be ready to go do your work. Homework 6. Okay, exponents. What are exponents? Exponents are the little numbers that go up here on top. That's an exponent. It tells you to take the base, which is the bottom number, and multiply it that many times. So 2 to the third power, or we might say 2 cubed, means 2 times 2 times 2. 5 to the fourth power, the base is 5, the exponent is 4. 5 to the fourth, 5 times 5 times 5 times 5. I think you end up with 525. Exponents get big quickly. M to the third, you can write up a long way, m times m times n. A couple of things you need to be careful about when you're using exponents and integers. Integers being positive and negative whole numbers, right? Look at the difference, very subtle, between these two things. One of them has parentheses, one of them does not. This one with parentheses tells us that we have to write that negative sign as many times as the exponent tells us. We write negative 3 times negative 3 because it's inside the parentheses 6 times. That means there's going to be 6 negative signs, and it will be a positive answer in the long run. However, this one, you only write the 3 6 times. You don't write the negative 6 times. There's no parentheses. It doesn't go with the exponent unless it's in parentheses. So bottom line, when the negative is not repeated, it just pops over here one time, you get a negative 729. When the negative is repeated 6 times, because it's in parentheses, cancels itself out, you get positive 729. You're going to see this a lot. You need to pay attention to it when you see it. There are several examples, and also just kind of a repeat. The base being making sure you know your vocabulary, being 3. The exponent is 4. If I wanted to list the factors, I would say 3 times 3 times 3 times 3. And then name the value, I would say it is 81, because 3 times 3 times 3 times 3 is 81. That's just really quick. I want to say that I did some of these on the calculator, and I put out a calculator demo video for you. There's lots of things in this video that can be done with the calculator, but I can't do it on top of this video, so I had to do it separately. You'll have to go to a different video to see these done on the calculator. Okay, negative 3 to the fourth power is in parentheses. The negative sign gets written 4 times. The 3 gets written 4 times. It turns out to be positive 81. Negative 3 to the third power, the negative 3 times negative 3 is 27, and 2 of the negatives cancel with 1 left over. This is going to be a negative answer. It just falls down 1 time. This is going to be a negative answer. It falls down 1 time. 3 to the third, we already know is 27, and 3 to the fourth is 81. So watch those parentheses, please. Zeros exponents. That's another weird one. 2 to the 0 power is 1. Negative 6 to the 0 power is also 1. Isn't it? If the negative 6 is in parentheses, right? 4 to the 0 is 1. 987 to the 0 is 1. All this mess to the 0 is equal to 1. It doesn't matter. This guy, the negative sign has to follow with him, right? So be careful about that. Exponent only goes with that whole number unless it's in parentheses. Really important, tiny little detail, a really important one to get in algebra. Okay, here we go again. Anything to the first power, you're not changing it, are you? When I say 3, I'm really saying 3 to the first power. Anything to the 0 power, whether it's 5, 78, or 13, always going to equal 1. Goodness, I'm having a hard time with my slides. So, zeros to the first power, and now negative exponents. Negative exponents in this right now, you're just going to have to take my word for it. And I promise you that in a homework demo coming up later in this unit, you will understand why they work better. Right now, you just kind of have to trust me that this is the way that they're going to work. So here's what happens. You have a base, and I'm going to show you that over here. Over here, my base is 4. With a negative exponent, my negative exponent is -1. Well, when that happens, it's telling me that negative sign is not making my number negative. It's telling me that I'm supposed to move that guy to the bottom of the fraction. And when I move it, I need to make the exponent positive. So 4 to the -1 becomes 1 over 4 to the first. Isn't that odd? Yes, it's odd. It's not hard, though. So get used to it, and it works. 7 to the -3. It's telling me put the 7 on the bottom, still to the third power, but change it to a +3. This one's cool because it points out, look, this -5, he stays negative. The negative exponent has nothing to do with the -5, and since it's not going to, negative exponents never make numbers negative or keep them from being negative. So the -5 is still negative, but when I move it to the bottom, because the exponent's negative, it changes that exponent to a positive. Let's just do a couple of those. I promise they're not so bad when you get used to them. So 3 to the -4 is really 1 over 3 to the 4th. Everything starts out over 1. Negative exponents tell us to move it. So if it starts out like this one on the bottom, it's telling us it wants it moved to the top. So this one is 3 to the 4th. By the way, we can keep going here by saying 3 over 81. Here, 81. This guy's kind of interesting. 2 squared. 2 times 2 is 4. It just stays on the top. But this 2, it has a negative exponent, so he needs to move up. So times 2 to the 3rd. So now I have 4 times 2 times 2 is 4 times 2 is 8, because 2 to the 3rd is 8, and I have 32. Again, you can do these in your calculator quick and easy. Look at the demo video for calculators. So that one will also help you with these, which are square roots and squares. And I just want to show you this kind of to get our mind right and to realize that, oh yeah, when I'm taking the square root of something, I'm looking for what would I multiply by itself to get that number. A lot of times I think about it like this. I have the square root of 9, then I have the square root of 3 times 3. I have 2 3's inside the house, and that means there's one guy, I would say, outside the house. So 2 inside is 1 outside. The square root of 9 is 3. Also important for you to recognize that you can usually think about with squares and square roots, an actual square, that if the side is A or 3, then the area is 3 squared or 9. By the same token, if you know that the area of the square is 9, then the square root of that is going to give you the size of the side. So playing back and forth with squares and square roots. Again, you can do these on your calculator. Just go look at the video. They're quick and easy. Square root of 81 is 9. I'm not going to do but a couple of these. 11 squared, 121. I'm just going to encourage you to go get on your calculator and watch how they work. Also, these cube roots. So if we can square something, 1 times 1 is 1. We can cube something. 1 times 1 times 1 is also 1. But 2 cubed is 2 times 2 times 2, which is 8. So cubed just means 3 times, right? And it would give you the volume, or how many little bricks you would need to, or you would build up if you built up 3 long by 3 wide by 3 high. You would have 27 bricks, because 3 times 3 times 3 is 27. The inverse of that is you can take the cube root of 27. Notice this little 3 here. When we write square root, we don't usually put the little 2 right there, but we just write the square root. But if we want it to be a 3, we have to put a 3 in the index. And the cube root of 27 is 3, pretty much meaning there are 3 3's inside, kind of like we thought a minute ago about there being 2 inside. For a square root, for a cube root, we're looking for 3 inside. So that's kind of the basic idea. And then they have this cute little shortcut way that they like to show you how it works. So, a little shortcut way they like for you to use, which is the fraction exponent. So hang on a sec, look up here with me and recognize first that this is the index. When we do a square root, we usually don't write the index. We could, and we would write a 2 right there. The square root sign is often called a radical, and you'll hear me call it a radical. And the guy inside is the radicand. So this 8 right here, that's our radicand. Now focus down here for a minute. The cube root of 8. Remember that meant I want 2 times, what would I multiply 3 times? And it turns out, oh, it's 2 that I would multiply 3 times. But here's the cool part. The cube root of 8 is the same as 8 to the 1/3. And what's really cool about that is this is easiest to put in your calculator. You can put a little caret, and then you put the 1/3 in parentheses, and you can watch the demo to see how to do that. But here's the bottom line. When you see a 1/3 as an exponent, you need to recognize that means they're looking for a cube root. And guess what? It works for square roots too, only it's 1/2. So 9 to the 1/2 is the same as the square root of 9, and that is 3. And here, the cube root of 8 is the same as 8 to the 1/3. These are exactly the same thing written differently. And that would be 2. Because 2 times 2 is 4, times 1 more 2 is 8. This is just sort of the short, a quickie writing of it. The half means square root, that 1/3 means cube root, and 1/4 means fourth root, and it keeps going just like that. So use that again in your calculator. Just real quickly, you're going to use your calculator to do a lot of these, but I'm pointing out the cube root is the same as 1/3. The square root is the same as 1/2. So what's the square root of 64? 8. What's the cube root of 64? 4, because 4 times 4 times 4 is 64. Quick reminder, this needs to go to the bottom, right? How about 0.64? Your calculator can do that, but you know that 8 times 8 is 64, so I think 0.8 times 0.8 is 0.64, and the answer is 0.8. Don't forget the 0 power is always 1. And don't let these fractions bother you. They're quite simple. This little negative guy just hangs out in front of our answer. And I think of this as the square root of 121 over the square root of 64. The square root of 121 is 11, and the square root of 64 is 8. Boom. If you didn't know 11 times 11 was 121, show if you're pulling out that calculator. Here's a great example of a floor where they're giving us the area, remember? And we had to take that area, take the square root of it to get what is the size of one of the sides. And I'll get an answer for a second square root, 289 on my calculator, and it's telling me that equals 17. So if the area is 289, then the sides of the rectangle are both 17. If a car skids to a stop over a distance of 60 feet, find the speed of the car. So this is a situation where a car is driving fast and you're trying to stop quickly, and they skid for, it says here, 60 feet. So they want to know, well, how fast? What was their speed if they're skidded 60 feet? So they just want us to put a 60 in for that. We'll multiply it by 24, and we'll take the square root of it, and that will be our speed. And I suspect I need to put that in my calculator. So I'm saying second square root of 24 times 60, and I get 37.9, which I'm going to call 40. I'm going to say, oh, not 37.9, it's not 40, it's 37.9, which is about 38 miles per hour. Nearest whole number for miles per hour. Not too bad, right? We have one more little formula that we want to plug into. It looks really complicated at first, but it's very straightforward and easy. And actually, this equation represents population. So what is the population each year, Y years from now? So if we substitute 3 years for the Y, we'll find the population 3 years from now. So we take this out, put this in. I can pop that right into my calculator, 2500. I'm going to put parentheses just like they did, 1.02. In parentheses, I have to push my caret button and then to the third power. And I get that there will be 2,653.02, but we'll round it to the nearest whole number as they ask. So we'll use these and put them in the calculator in CC as well, these two formulas. Here's everything kind of wrapped up. I hope this helps you out. It kind of gives you all the little rules of using zero and negative exponents, parentheses, and fractional exponents. A lot to look at, but if you use your calculator, I think that it will work out and you'll see that it's not too difficult. So go practice your homework. I hope to see you soon in CC or in TOGA tutoring. Take care.